Thome, and for those of you who don't know, and as Kristen said, I'm Vice President of Strategy for Industry Standard Servers and Software. Which is a mouthful for me to say Monday morning. But anyhow, thanks for coming out, guys, and we appreciate the opportunity to get to share this with you guys. I was asked to come in and talk about Gen8. I'm going to talk a little bit about Gen8, but I'm also going to talk about just kind of why we're doing what we're doing and kind of the overall kind of big picture thinking. You're actually going to get some more details on some of the particulars of Gen8 as we bring in some of the other experts in some of the various areas over the course of the day. So with that, I'll go ahead and jump in and start talking. And I think you already saw this slide once before, right? This morning. But what I want to do is really kind of talk about kind of why we're doing what we're doing. So Moonshot, obviously that's really kind of aimed at a specific segment of the marketplace, with the kind of the extreme low energy computing. Odyssey, kind of same thing, really kind of bringing mission critical and x86 together. Some big things there. And as Jim, I'm sure, said, we kind of announced publicly these three initiatives really over a course of about 100 days, with the intent of really kind of transforming big chunks of the server industry. And so the third one, Voyager, is the one that really is kind of this multi-year journey, multi-year mission, if you will, to really address kind of the core of the x86 marketplace. And so in many regards, what we're doing with Voyager actually applies to the Moonshot and Odyssey as well. So it's a very broad-based kind of initiative. And we say here, kind of redefining expectations and economics at data center, but it really starts, really at the core with kind of rethinking how the server operates and, how a server ought to operate in real-world environments. And so we think about a few things as we're kind of going down Voyager. It's like, what are our mission goals? And hey, this is, a mission, right? So we've got to have mission goals. And, a few things. One is we want to help customers get the maximum uptime out of the systems with the least amount of effort on their part. So, we want, our systems up and operational, so they're doing what they're supposed to do, which is run applications, run people's business. And we're doing it with the least amount of effort required to get yourself there. We want to deliver, the desired performance for applications that people want, and do it with the least amount of power, least amount of space, least amount of cooling, so kind of be able to really be very efficient in how we do those things. And we want to help customers get their applications and their services they're delivering up and running faster. And so those things right there are really kind of define what we're doing with Project Voyager and the mission space, mission field that really is, the industry standard server environment. So it's a pretty broad-based initiative. And within this context, this is actually multi-year kind of a thing. This is not something you just tackle and be done the next day. But it's something that actually takes quite a bit of time to go do. And so the ProLiant Gen8 is really kind of the first step on this journey. And as we go through and kind of learn more about the what we're doing with Gen8, you'll kind of get the context behind that in terms of why we're doing what we're doing, and you'll perhaps start getting this, get some kind of feel for where we're going to be going in the future as well, when you really kind of think about this from that perspective. So, we announced the Gen8 servers in February, ProLiant Gen8, and this is like I said, kind of the first step on this Voyager mission, and obviously we're really excited about what we're doing and what we're bringing to bear with Gen8. I'm going to spend some time, really, immediately time talking about that. But I want to almost kind of even get a little context behind this. I mean, obviously you guys know we're the #1 server manufacturer out there. And one of the blessings comes with that is that you get to talk to more customers than anybody, and we take that real seriously. Every customer interaction we have, whether it's with one of our engineers that's doing the design work, or our field engineers, or our services engineers, or whatnot, we're talking to customers all the time, every day, and of course all of our salespeople as well. And so we're really talking to them and we're listening, and we're hearing kind of what's going on, what they need. And actually for Gen 8, we did, I think, kind of the most exhaustive things that we've done ever. I mean, we actually have synthesized over 100,000 customer interactions and synthesized the feedback from all that information from customers. And synthesized it down to saying, what are the real things that's keeping customers from doing the things that I just talked about, with mission goals, from, helping them get their systems up and running, keep them, maximize uptime, least amount of effort, performance, things like that. What's inhibiting them from that? And when you have this much information, this much data, you really have a lot of information to run with. And so we really have taken this information and started using this to really help us kind of shift and form our R&D strategy. And so, of course, R&D, $300 million investment for ProLiant Gen 8. We're taking a lot of money putting into this. And when you got that much customer data coupled with the great technologists that we have here, you can meet some of them today, you're not surprised that you get some great results out of it. Yes, please.
Is that amount of R&D investment for the current generation, the new generation, very different from the previous one, or is it much bigger? Or
this is
in the previous version.
Yeah, great questions. So questions, how's this compared to previous generations? So there's some focus areas, and I'm going to hit on some of them, that we really put a lot more emphasis on and spend on than we have in the past. To really, to deliver on the things that we're hearing from customers saying that they want out of it. So this is a significant investment for us, certainly compared to like the previous year or two or three that I've kind of been watching closely on. And so the cool thing is, we're putting more investment in this. We're doing the things we need to do to bring the innovation, to bring the quality, to our customers and the stuff they want. And obviously, there's a lot of new innovation that comes here. We've got a lot of patents out of this as well. And the patents, I think, is kind of one reflection of the innovation. But I think the big reflection of innovation is going to be the product itself and the experience that customers have with it. So, does that answer your question? No, I did not answer it.
I was wondering, is it once, twice, 3 times, 4 times?
So we don't actually split out at that level of detail how much, but there's some areas that were significantly more, and some areas I think we probably were double the investment over a previous generation. But in sum total, we don't split out the particulars on it, how much we've done, but it is more than we've done in the past. And like I said, in some areas substantially more. Sorry, I can't give you all the detail. And actually, to be honest, I don't know all the detail in my head, but there's even.
Well, it's difficult to place it. It's a lot.
Well, and so when I go through some of the key innovations, I'll kind of point out these are some of the areas that we really did spend a lot more time and a lot more money and a lot more people investing in to kind of create some of these technologies. So that'll become apparent as I go through this. All right, does anybody else have any other questions I can't answer? I'll try, I promise. So actually, this is really where we're going to spend the bulk of my time talking. One of the first things that we did is we developed the concepts for what we're doing with ProLiant Gen 8. And as we kind of talked to all these customers, listen to all these customers, listen to all this feedback, we really realized that customers, when it's just, I'm just going to start with just kind of like the real simple stuff. I mean, you want to buy a server. What do you want your server to do? Well, you want it to run your application. You want it to run well in your data center. You want to be able to manage it. You want to be able to support it. Just the basics. And what we found is, going through this is that servers, we believe, really just needed to be smarter. They needed to be more intelligent about what they're doing, and not just about kind of the I need CPU and memory to run the application, kind of the basics. I need to be able to transmit data over the network. I mean, everybody gets all those things. But when it comes to really kind of thinking about, what is the experience I want to deliver to the application? What does the application need from the server? And the found is, actually, there's not a whole lot of information that, is transmitted at kind of that level of knowing kind of what you're really trying to accomplish for the application. The administrator, same thing. We wanted to deliver a really great administrative experience. And again, what we found is, you know, there's just not enough intelligence built inside the typical server to really be able to deliver a great experience. I'll hit on some particulars as I go through this. The data center, same thing. You know, if you, I mean, basic things like, hey, where's the server in my data center? How hot it is it, you know, around there? Well, that information is just not readily available on a typical server. And so even the basic stuff that you need to kind of manage your data center environment, not there. Support, you know, it's kind of amazing, but you think about it. The server knows when he's down, he knows he's down. HP probably knows how to fix it. But we need to know if there's a warranty which is held somewhere else. So the information is all known everywhere, but it's not connected in a meaningful way. And so as a result, the support experience tends to be kind of very manual, and lots of little things kind of can hinder it. And this is really kind of the experience with all typical servers. And so what we needed to do is create a server that was not typical. And so with the ProLiant Gen8, we really kind of felt like we needed to create a server that had a lot more intelligence in it. And this intelligence is what we call the proactive insight architecture. And we've embedded this in every single ProLiant Gen8 server. I'm going to walk through and talk about kind of some of the things that we've done and why we did them to kind of deliver what we think is a better experience all around. So, you know, start off talking about the proactive insight intelligence. So basically what we've done is we've taken a lot of things that used to sit outside the server, and we've embedded it in the server. You know, so and I go through this all kind of through, whether it's things like you know, agentry, device information, health information, you know, kind of what do I do now information, just lots of things that typically has to be managed outside of the server. And we said, you know, if we put it in the server can actually start managing itself for these things. And not only put this intelligence in the server, but then start connecting it out around to the relevant parties, so connecting it to that intelligence to the application, connecting it to the administrator, connecting it to the data center, connecting it even to the support experience. And so this is really kind of what we're all about with proactive insight, is really kind of putting this intelligence, if you will, into the system and getting a better experience. And so what we've done is we've gone through and, you know, literally on the motherboard servers, and we've got, you know, a sea of sensors built in, you know, obviously to be able to sense everything that's going on in there. But we've also embedded things like what we'll call our new active health system that's basically will monitor the system and make determinations on what to do. So we have kind of policy information built in. We've got logging information built in on the motherboard to identify what's going on. You know, we've got device, you know, drivers built into the motherboard. We've got the agents built onto the motherboard, so you don't have to load it in an operating system. So we've built all these things, and all these things collectively is stuff that we kind of think of as intelligence. And I know a lot of times we think about this as kind of, you know, management stuff, but it's actually a lot more than that, because it's not just about extending the kind of the management experience for the administrators, really about serving, you know, multiple constituents that really kind of care about what's going on in the data center and care about what's going on with the servers and applications. So we've taken all this stuff, embedded it on the motherboard, and then started extending it out. So first place we did is what we call the integrated lifecycle experience. And basically what this is really is we, you know, thought about, okay, so if I'm an administrator, you know, and I want to, you know, manage my servers, what are the basic things I need to do? So first thing I need to do, I need to get the server up and running. And then, you know, every once in a while I may have to do some sort of maintenance on the server, maybe it's firmware updates or, you know, other things like that. And if it breaks, I need to get it back up and running again, right? I mean, this is kind of basic information. And so we went through and looked at, you know, each of those things and said, well, what can we do to make those things better? And not only how do we make those things better, but how do we take that knowledge and put it onto the server itself so that we can really do it itself or do it more easily with the person having to manage it. So in the kind of the initial startup, what we did is we, you know, started with a couple simple things. It's like, okay, well, let's see. If I got to get a server up and running, you know, some things I need to do is I need to configure the array, I need to load the device drivers and stuff like that. Well, rather, typically we put all those in DVDs or you download them from the web or something like that. And we figure, well, there's a much easier place to store all that information, which is on the server itself. Because if you're trying to get a server up and running, well, if the server itself has everything you need to get itself up and running, that's kind of the best, simplest place to look for, because you already have the server. And since you already have the server having everything you need to get the server up and running, right there. So keep it simple. Embedded on the server is something called intelligent provisioning. And intelligent provisioning basically is a kind of a guided, step-by-step, walk you through getting the server up and running, getting everything you need to do. And you can do it, kind of first time, sit down and do it yourself, get it up and running. Or we also have, scriptable interfaces and programmatic interfaces that allow you to do it kind of in a batch mode. Yeah.
When you buy a server, this software tends to be out of date all the time. Is there a way to first synchronize it and then do the installation?
Yes, so we can also synchronize it and update it as well. Yeah. So, and it kind of it depends on what kind of software it is. Some of it obviously spins more often than others, but yeah, we can provide you the mechanism to upgrade as well. Things like the firmware and devices on the system. So anyway, so we get the thing basically up and running very quick. In fact, in our own testing, we're basically able to do this like 3 times faster than kind of previous processes and previous steps to get things up and running. And so just kind of simplify the startup experience. Keep it simple. Where we have opportunity to continue to simplify, you'll probably see us do more in the future. But we've got some real simple metrics, which is get the system up and running quickly without having to hunt down for anything else. Just have it all fully contained, ready to go. The second one, to your point, maintenance. So I need to get things back, refreshed up to more recent versions of firmware or drivers and things like that as well. And so. And by the way, things like firmware update is become really kind of an industry challenge. When you start kind of looking at all the different firmware types, from your NIC to your storage device to your management device, system ROM, and so on. There's a lot of different components, and there can also be dependencies from one component to another. So this has to be installed before this can be installed, sort of thing. So what we've done is we've built out something called System Update Manager, or HP SUM for short. You're going to talk about this. That basically goes through and can do all the updates, but what it does is it actually first it'll check to see what updates are available and what updates are needed, and then it will do the updates. It will handle all the dependencies and sequencing automatically for you, so you don't have to do any of that yourself. And I can do that on the system I'm working on, or I can do it across many systems at once. And that capability is available at a utility, but it's also built into the motherboard of every Gen8 server, so it's always there, whenever you need it. So here you basically have something now that really kind of takes something that people see as a very complex process of handling all the firmware updates, the dependency checks. Have to schedule, manage reboots if need be on some components, spread across one or many servers, consolidate it down to a single process, single tool to handle all those complexities. And then we'll also handle the firmware packaging for you automatically, because we will deliver, tell you, here's the firmware updates, here's the firmware updates that are tested together that you can use to do upgrades on and so forth. So a very powerful set of capabilities there. And again, testing here, we get threefold or greater time reduction in terms of how long it takes to do this. And we've actually tested this at scale. So we did this with a customer that we'd gone through and done some firmware updates, and then we took in the System Update Manager at a future date, and we were able to do the system update again. And we found that we basically could do the firmware updates 3 times faster. And this is like a real-world large deployment, so it wasn't a synthetic kind of environment. We're able to go 3 times faster, and also cut most of the downtime for reboots as well, because the tool handled that in a much smarter way, basically, to do it all. So some great stuff there. Third thing, so what happens if something breaks? So what we've got is, as I mentioned earlier, is we've got this brand new system built inside every branch in it called the Active Health System. And the Active Health System is basically there to, first off, monitor everything that's on the server, pay attention to it, kind of what's going on with it, and see what's what's working, what's not working, what's working well, what's maybe kind of at risk of not working well, and really looking at everything. We got literally over 1,600 points on the server that we're monitoring at any given point in time. Now, it's not just monitoring that matters, but also catching the failures before they happen, or catching them after they happen if it does. And so we've got pre-failure capabilities as well as failure capabilities. But the new stuff that we have with Active Health, and of course all this stuff we've had before in some form or fashion, is really start to integrate and close the loop on how we do things. So now when we catch a failure, let's say it's a pre-failure, we go through a couple different scenarios. What we can do is we can take all this failure information, save it out, but we can also transmit it automatically to HP support website basically. And so we can take, hey, hard drive failed, or had a multi-bit memory error or something like that fail, and take all this information, package it up, and send the failure information to HP. Now once it comes to our support center, then we can automatically know what the correct response is, whether it's send on another part, send on a person, get on the phone, or whatever. And then we can also transmit as well some additional information about the server, and with the customer's request, to basically kind of cut through a lot of the stuff that you normally have to get, just kind of the basics, on a server, like, hey, what's the server name, what's the model number, stuff like that. If you're on the phone, kind of, talking to a support person, you have to answer all these standard questions first. Well, all that information we can just, ship automatically. So the Active Health System now is really about integrating the whole experience from the failure all the way through to the support experience as well. And I'll talk about the support experience more in a little bit. But basically we're able to really kind of automate this whole thing in a much more closed-loop fashion. So with all these capabilities, again, we're able to do first-time proper diagnosis much faster, and we know from our experience already that we can deliver kind of industry best experience in terms of first off getting from the failure to diagnosing the problem, and the second thing is also diagnosing the problem properly. So getting the first time show up with the right part number, part and stuff like that to repair. And so this, it's meaningful, difference for customers. And I don't know, for any of us who've spent time trying to sort through complex problems, having the system itself know a lot more about what's going on with it is tremendously helpful. So rather than having to say, I think it's this or this or this, the system will tell you. And one of the interesting things is we actually, when we have a failure, we, of course, we log that information, but we don't only log it on, like an operating system does, we log it on the motherboard, we also log it on the failing devices itself. So like if you have a memory failure, the DIMM itself that has the failure on it will actually mark itself as bad. And so this is part of our smart memory DIMMs. So, kind of the typical process may be you get a non-correctable error, and then you say, well, go run diagnostics and have diagnostics try to prove that the DIMM is bad. Well, with Active Health System, it actually works the other way around, which is Active Health System says, hey, we found a memory error, and the DIMM itself is saying, I'm bad. And so the DIMM proves to you it's bad versus you having to prove the DIMM is bad, if you will. And so that's kind of a simple thing, but it's real world, especially since memory failures tend to be some of the areas that tends to fail a lot. Is when the DIMM itself knows it's bad. And let's say that you're kind of troubleshooting in late at night or something like that, and you pick up the memory and put it in another server to see if it works and not works, and you kind of forget what you're doing because you're kind of moving things around a lot. It just happens sometimes. The DIM won't forget. So you move that DIM to another server, and he still says, "I'm bad. This is my bad location." And so so even when you're doing things like that, will help protect you.
Will you disable that DIM then?
Yeah, it'll come up during when you power up and say, this is a bad, bad location or bad cell or something like that. So, prevent that. So those things right there. So kind of the intelligent provisioning, the smart update management, the active health system. Those are the things that we're doing. I mean, 3 big new technologies aimed at really kind of simplifying the lifecycle experience of managing the server. You guys with me so far on this? So that's kind of this whole bucket here. So the next big bucket is dynamic workload acceleration. So an interesting thing is going on over the last few years. You guys have all observed this. Processors have been getting faster. Memory is getting faster. Drives have not been getting faster. Now, and it's not that they're not getting faster, but if you look at kind of the performance boost of CPUs and memory and things like that, they're going much, much faster. Drives have been going at a kind of the mechanical devices, they've been kind of not going so fast. Now, the thing is that as you guys know, data is exploding and people are putting a lot more data on their systems. And so you wind up with lots and lots more data getting stored and processed and handled on devices that are getting, relatively speaking, slower and slower compared to the processor. And so you wind up with now is, in today's world, the number one application bottleneck is not CPU, it's actually storage. And we see this, kind of more and more, and we've actually gone and done some analysis on this. And basically, what we observed is customers are actually spending more money on servers that are storage bound, running applications that are storage bound, than they are running servers that are compute bound. So, I mean, it's getting to the point where storage is definitely a significant, significant, bottleneck up front. But the good news is that, obviously the trends these days are solid state storage. And so what we've done is we've, put into our ProLiant Gen8, we've obviously got, the newest, latest, greatest processors, and you hear about that. We've also coupled this with a new smart array technology that is built for solid state and, solid state optimized. And so what we've seen is huge performance boosts in the storage subsystem when we go with solid state storage. So we're actually moving from kind of rotating media to solid state. And so we're able to really kind of deliver some great performance characteristics here. So we've got, just in terms of, raw performance, capabilities. And actually, I'll cite the kind of the biggest number first. But if you look at kind of where we're with the ProLiant G7 servers on storage IOPS with mechanical drives, which is kind of what we launched with on the day 1 of ProLiant Gen 7, to when we launched ProLiant Gen8 day 1, we're actually with solid state drives. So of course, I'm doing a technology shift generation over generation, including controller changes and drive changes. But the raw storage performance is 100 times faster. So I mean, it's just huge boost. So the processor guys, like Intel, have been doing a fabulous job of getting processors, running faster. We're now starting to catch up with getting the storage running faster as well. So so that's so what we've done is we've built this whole thing optimized for solid state storage, with lots of little things built in. So really designed with the intent of being able to put the data in the hottest data in the fastest place, if you will. So we've got data. Obviously, you can store in rotating media. You can also store it in solid state. But then we also have a caching architecture that we've implemented, and the first version of it is already in place, where we're caching data in solid state. It's actually solid state backed DRAM. So we're able to run data at incredibly high speed in and out from a caching standpoint as well. And then we also do a lot of algorithmics as well. So like one of the things that we do with this is, one of the big trends obviously these days is virtualization. And one of the interesting things is if you have an application that's accessing data, it may be accessing it in a fairly sequential manner. But when you have multiple applications running on a single host, each as a VM, what the storage subsystem doesn't see is a bunch of sequential coherent data streams. It sees a whole bunch of gibberish stuff because it's all intermixed together across multiple applications. So it looks a lot more randomized. So what we've built into it is basically algorithms into our smart array that in effect de-randomizes the data by kind of reassembling it back into the proper order on a per VM basis, and then able to handle the reads and writes in a more coherent way in and out of the storage subsystem. And it's just lots of little things like this that really start paying off in the long run in terms of delivering the best application performance. You can hear a lot more about this as we go on over the course of the day.
Does that reorder not cause latency and speed slowdown?
Well, so the reordering, so this is part of the algorithms, is knowing when it's okay to reorder and when it's not okay to reorder. So there's a lot of smarts that go into kind of knowing how to do that, and an algorithm tunes itself as it runs as well too, to kind of decide what's the right things to do at any given time. So, but yeah, I mean this is part of the doing the hard work of paying attention to the details.
Is that algorithm pointed at a particular hypervisor, or could it be anyone?
Any hypervisor will do it. So it is designed to just kind of recognize what's going on as it goes. So third big area, the data center. So yeah, as I said earlier, it's interesting. If you're running a data center facility and you go ask a facilities person, hey, what's happening in your data center? And they'll say, well, I dropped a 30 amp line feed into this rack, and then I know there's a bunch of servers in there, and after that I really don't know what's going on. I don't know how much of that power is actually being used, how much energy is being spent on that particular rack or the servers in that rack, or I don't even know what the temperatures are, so I don't know if I really have cooling capacity or not, without going out and doing it. And of course, you can kind of find that out by kind of going around with a clipboard and looking at everything and taking a bunch of asset tracking and putting on you can put sensors in the rack to measure the temperature somewhere in the rack and stuff like that. But the interesting thing is, we're like, well, wait a minute, the servers actually kind of know a lot of this already, and so what we've done is we've taken a couple things from that. So one is obviously, we have temperature servers inside every server. We've got temperature sensors there. And then the second big thing we've done is we've built in power discovery services on our servers. And so our blades already have this where you can tell exactly how much power each blade is using. But we've extended this by putting in what we'll call an intelligent PDU, power distribution unit, that has the ability to do a couple things. One is it can monitor how much power is being used by every server on the fly. And so, get real-time statistics and then be able to collect all that information. The second thing it does too, by the way, also is you also detect wiring errors. So like if you hook up a server, both on a Gen8 server, you hook up both power supplies to like the A feed or both power supplies to the B feed, the B power feed. We'll say, hey, by the way, you just wired yourself up non-redundant. Is that what you meant to do? And so we're able to even track, catch some of these, wiring mistakes that people typically make. So basically, what we're able to do is help customers do those things. Now, the third thing we've done is a new innovation with Gen8 as well as added location discovery services as well. And what this does is it basically allows a server to know its location in the rack. So I'm in U number 37, or I'm in U20, or whatever, and do this. And so now, when you have those three things together, location, power, and temperature, it gives you an interesting place to be. Because now you can say, I know exactly what's in the rack, where everything is, what the temperatures are in the rack, how much power is being used by which devices in the rack at all time. And we can take this information, collect it together, and expose it to the server admin, but also to the facilities people as well.
How does it determine that location?
Well, so what we've got is the client servers themselves have a sensor that is actually on the rack ear, the ears itself on the server, and then we have an option for some of the racks where you can buy the rack pre-configured this way that has a location sensor strip that goes up and down the rack.
can that strip be added to existing racks and data centers? Or does it have to be on a new HP rack?
It does not work on every rack out there, but
But
it
if I
does
was-
work on the new ones, and I don't remember off the top of my head. You can ask the question again later when we get the right person in, which racks it does and does not work on, because I don't know the exact list.
Most people tend not to replace their rack every time
Yeah,
they put a new server
yeah,
in.
I know. So we recognize it's gotta be able to retrofit to some, so. But it does not work on every single rack from every vendor anywhere, you know. But, you know, being able to do this obviously is some kind of interesting capabilities now. So all this stuff right now is very manual and very, you know, time intensive, and tends to be, because it's manual and time intensive, you know, your data is, you know, slow and out of sync from reality. And what we do now is we can provide all this information real time, and so help manage the actual data center facility itself better than we could before. And, you know, you can see just right away, it's like, okay, well, this is, you know, lots of opportunities to improve things. So the fourth area, it says proactive service and, I should say, support. Somewhere or another, the slide didn't follow through with this. And so this is really, you know, I guess kind of in a way our fourth constituent that we think the server needs to service. You know, so we need to make the apps run better. We need to make the admin experience better. We need to, you know, make the data center run more efficient. And the fourth things we want to do is we want to make the support experience more delightful. And so what we've done here is we've invested in a significant new technology we call Insight Online. And Insight Online is a web-based portal, so it's kind of a cloud-based application focused primarily on support. And so within the support portal, some of the things we can do today is be able to, one is help customers, you know, they can log in and they can see exactly what servers, you know, they have, what their IT equipment is, and we'll track it from there. We'll track their warranty information, stuff like that. And if you remember, I said earlier, the servers know how to transmit failure information. Well, it'll show up in this portal as well, so the customer will log in and see, okay, this server, you know, had a problem with it. It's under warranty. Here's what your entitlements are for what's going to happen with it, and stuff like that. So you can get kind of complete support snapshot of your, you know, of your environment online. And since it's online, we can link it with HP as well. So it's not just a static web page for you, but it's actually an integrated experience where, you know, our support people can see, oh, you have a problem, and then, you know, handle it appropriately. But over time, we can integrate this more and more deeply with everything that HP has online and be able to deliver.
Is that an added cost, or is that anybody that buys a Gen 8 box?
If you buy a ProLiant Gen 8, you get an Insight Online. It's no additional cost. So, you know, I think some really cool capabilities here, because now we can, you know, do the automated closed-loop feedback of, you know, system failed, we get notified, we can determine, you know, yes, you're entitled to this level of support, deliver it to you, and you know, as I was kind of alluding to earlier, you think about the, you know, the typical experience. Server failed. I have to know it failed. You know, I personally have to know it failed. You know, the tool may have figured it out, but it tells me. Then I have to call up HP, go through the whole, you know, support thing, and you're like, okay, what's your name? What's the company's name? What's the server? What's the server name? What's the server serial number? You know, blah blah blah. You're answering all these questions, and it takes a while to kind of even just get through this. And I know any of us who've ever called tech support for whether it's for a server or a laptop or anything, is, you know, there's a process involved in getting all that information. Yeah.
I guess this goes across a public network.
Yes. Yeah. It'll go across public.
What way is this
Securely.
information protected?
Yeah, it is. So it's a secure network, protected. The information is that's on there is just about things like the failure. You know, so it's like this drive fails. You know, and you know, of course, anything that's transmitted is done. You know, I mean, the customer has to choose to do it. You know, say, do I want to let it transmit or not? Yeah. So it's that level of stuff, and then it's encrypted after that.
No certificates or something?
Yeah. So what you get now from an experience standpoint is, because all that information is known by the system, known by the Insight Online, and talks to the server directly. It's known what the problem is. who the customer is, how to correct it, and what to do next. And so even before you call us, we may be calling you with saying, here's what the problem, here's what you need to do, or here's a part on the way, or whatever. So we're able to kind of deliver, we believe, a vastly superior support experience. Now, that's kind of for reactive support. We also want to be able to deliver better proactive support as well. And so we actually have a set of proactive services, support services as well, which can help catch problems before they happen. So this is including things like providing, periodic scans of your environment to see if you're in compliance with kind of best practices or not, and making suggestions on things you might do differently based on those things. All right. So basically, this is the proactive insight architecture. So I kind of went through the whole thing, 4 big areas: lifecycle, application performance, data center, better data center, and then better support experience. So huge big areas. We see these areas as really areas that customers tend to be very passionate about, very excited about. Users, this is kind of the things that they need to make their operations run better. And so this is really our focus areas for proactive insight, but also for Voyager overall, starting with the Gen8 servers. Now, in addition to the embedded, architecture and that we've built inside the Reliant, we've also paid a lot, attention to a lot of little details, and some things that we've seen is, is there's areas that we can do just to kind of simplify even the walk-up interface with it. And we're just going to highlight a couple things real briefly here, but then you're going to get to see these a little bit later on, and these and more and stuff like that. Okay. So one of the things that we did, and this is actually one that we collaborated with Intel on, is something we call the Smart Socket Guide, where we found one of the leading causes of motherboard outages is actually it was actually on account of insertion problems with processors. And so what we did is we developed a new socket that basically cradles the processor and puts it just perfectly in place every single time. And you think about it, if you have a bent pin on a motherboard, then your motherboard becomes unusable. It means that your application's not running. Yeah, you got one here. Great. Password, yeah. So, so this really addresses, some of the, leading cause of motherboard failures. The second thing you hear a little bit later on today too is our new drive carrier has an indicator on it. It's shown up right here. It's called a do not remove indicator. One of the things that we've observed, and of course, if you use, we have RAID, and most customers use some RAID 5 or higher level of protection for data. But if you're running RAID 5 and yet you lose a drive, then obviously you're down to you need to swap it out, or else you'll lose data. Well, unfortunately, we do have, and this happens like every week basically, we have customers who go in the data center and they're not paying quite as close attention as they intend to, and they pull the wrong drive out. So, if you've already down one drive and you pull a second drive, then you can lose data. If that's the RAID configuration you have, and we don't like that, So what we've done is we put an added level of feedback for customers that when a drive is in a state where it's pulling out would be a problem, we put on this additional indicator that says don't remove the drive, the do not remove, as a kind of an additional visual indicator to make sure people know, not this one, and help customers kind of avoid this human error. So, and the reason why I bring this up is, we're and this is some things that you're asking about. Where are we really investing in improving on? The proactive insight, as well as just all these little details like this, to really help customers, avoid problems before they happen. To help customers, with things that just still little nitpicking detail things that can cause problems if you're not careful. and really kind of address some of those big issues. These are a couple of big issues that we've seen crop up, but there are many, many other ones behind this. And when you get the tear down of the Gen 8 later on, they can walk through and explain a lot of them and show you, well, we did this because customers were having a problem with this. We did this because customers were having a problem with this, and so on. So we took all these new ProLiant Gen 8 innovations and we've put them across the board for our ProLiant Gen 8 family of servers. So we have our rack mount servers, our blades, our tower-based servers, and then our density optimized servers that are really designed for kind of the most extreme data centers. But we've taken the same technologies that I've talked about and embedded in every ProLiant across the board. So irrespective of what ProLiant is the right ProLiant for a given environment, all these innovations are available all the time. So with that, I think I'm right at time.
Right on time.
Yeah.
One whole
So,
minute.
so that's a kind of a quick overview, and you'll get to hear more about the particulars of these things. So I just wanted to give a quick flyover. You're going to hear a lot more stats and details as we go and stuff like that. But hopefully you get a sense of just kind of directionally, where we're going with this Project Voyager, and we're launching, if you will, with ProLiant Gen 8 in terms of really kind of bringing some to bear, really addressing what we think are some of the challenges that customers face day in day out with their IT infrastructure.